Hi, statistics learners. In this video, I want to show you how to simulate a coin toss experiment. Okay, this is for basic probability using R. So as you know, a coin flip is a very typical example showing you probability, especially how probability is defined from relative frequencies of the number of event of interest over the total number of experiments. Okay, so let's define a variable called outcome, which is heads and tails, and we set p underscore heads equal to 0.2. So that's the probability of heads. So it's not 0.5, so it's not a fair coin. So we're doing a biased coin. We do 100 flips. For reproducibility, set up a random seed using today's date. And then we can simply use the sample command. So sample outcome, size equal to number of flips, replace equal to true, and then probability equal to p heads and minus p heads. Okay. So if you do that, you store everything into sim under unfair coin. So you can print out the heads and tails. So here the relative frequency is 25 over 100, so about 25%. And remember the true probability of seeing the head is 0.2. All right, so that's pretty easy to simulate one coin toss experiments. And I want to do more, especially I want to do a sequence of coin toss experiments with the number of coin tosses increasing. And then I want to plot out the relative frequencies of seeing a head and just demonstrate its convergence when the number of coin flips increases. Okay, so let's write this R function called flip and fair coin function. You ready number of flips and probability of seeing a heads. And you can see it's first you do create the outcome, the sample, size equal to flips, replace the true, probability equal to that. And that's the function you do one coin flip. Okay. And now we assign p heads equal to 0.3 and maximum flips 1,000. Okay. And now we are gonna define a numerical vector called the relative frequency heads. And then set a random seed. We do a for loop from 1 to maximum number of flips. So what you do is you flip the coin, and then you put in the relative frequency into the numerical vector until you fill up all the position, all the components of numerical vector. Then you get the vector of relative frequencies, and then you can plot it out, with the from 1 to maximum flips, and the y-axis is the relative frequency heads, and you can use the line type equal to line, color equal to blue, line width is 2, and x label is number of tosses, y label is relative frequency of heads, and mean is relative frequency of heads versus number of tosses. Add an AB line, and then legend. So you can see it's a relative frequency of heads versus number of tosses. You can see we went up to 1,000, but you can change the number of maximum flips, and then it will converge to 0.3, which is the true probability of seeing a head in a single coin toss. So this is an example showing you how we can define the true probability of a random event as the limit of relative frequencies in a sequence of experiments when the number of trials increases. Okay. All right. Thank you for watching this episode.